setting reset. And then what I'm going to do is, variable x and a. We're certainly doing Wells's technique now. I'm not going to finish it out though, but I'll start it. And what's that going to be? X and a are my variables. I'm going to define a function. And this function is actually going to be x4. It's a fourth root problem. Let's see, minus 7. And what we're trying to do is come up with an initial guess to that. And a good initial guess that would be about 1.6. All right? So let me go through what Wells's technique is. We'll match his numbers. So I can say 1.6 is a good initial guess, but there is some correction on that. And I'm going to say it's a tiny number a. I'm going to expand it. Hit the return button. And I think you probably recall what we've done in the past. At least I hope you have. If you've been paying attention. We solved the linear part of it for this root. So I'll do that over here. And again, this would have seemed like a miracle to Wells's people. And I get this number, and that's my correction. So I'm going to take the number 1.6, and what we're going to do is add the correction on. And this is the correction. No, I'm not going to retype that. I'm going to do a copy paste. And I get this number. This is the new correction, or I should say my new guesstimate. So I got this over here. I want to point I got this right over here. Same thing. If I want to get the next one, and the reason I'm getting the same numbers, I'm using the same seed value of 1.6. Let's do the next one. So I'm going to copy this number here, and I'm going to do another correction. So f of that number plus a dot expand. I'm just going to do it twice, by the way. And then I'm going to take the linear part of it. And again, the reason I have a is tiny, that will have the most impact on the number, not these original terms over here. So I'm going to say solve. And what would you go over there? We're solving that for its root. And we'll make our next correction, which is going to be this number here. That was our last guesstimate. And then we're going to decrease it by this. Let's do that. And what do you get? Let me just pull this over. You can see what we're getting. We're getting the same number we got there. And again, I got to keep going through that. And again, it was quite remarkable that they were able to do this with human computers, right? Digital computers. I'm not amazed by that at all. But what I really want to do is I want to see what the fourth root of 7 is. Now, by the way, there's actually 4 of them, but we're only looking for what's called the principal root. And that's going to be to the 1/4 power now. If you want, you can put down 0.25. And, I want to point out, looking at it, it's remarkable how good this was to getting to that level of accuracy. It really is. It's quite remarkable. All right? Thank you for paying attention.